moles and molar mass. It's what we're going to be looking at today in this video series, and we're going to see how to convert to moles, what a mole is, and what molar mass is, and why it is so important. So to begin our discussion of moles and molar mass or formula mass, we need to first look at the idea of the mole. And the mole, remember, is a counting unit. So like a dozen means 12, and a gross means 144, a ream means 500. A mole is 6.022 times 10 to the 23 pieces. And so that's just a number that it equals. So when we're looking to compare things, like comparing a dozen eggs with a dozen cans of pop, while they're different masses and different sizes, they are the same number of pieces, and so we can compare two things that aren't the same by setting the number to be the same. So a mole of gold has the same number of pieces as a mole of hydrogen, even though we'll find that they don't weigh the same. So there are exactly 12 grams of carbon-12 in 1 mole of carbon-12, because carbon-12, the 12 is its mass in AMUs, and so if we have a mole of carbon-12, or 6.022 times 10 to the 23rd pieces, that's equal to the mass in grams, which is 12. And we find those numbers on the periodic table. Avogadro's number, which is what 6.022 times 10 to the 23rd is called, it's in honor of the Italian chemist Amedeo Avogadro, and he proposed that there was a number for the mole, a number of pieces or atoms or molecules or whatever. But he did not come up with the number. It was found much later, but they named it after him. Now, if we need to convert to moles, so we're going to ask how many grams of lithium are in 3.50 moles. So the first thing that I have here is the box on the periodic table that contains lithium. And you'll notice that I've already circled the mass of lithium, the atomic mass. The atomic mass is also the molar mass. We just have to change the unit to grams per mole, because that means that we have a mole of it. And so if we look at our conversion, how we want to do this, again, we're going to use our factored label method. So we'll start off making our grid. And we put 3.5 moles of lithium, and then we need to figure out what we do with the molar mass. So remember, the unit for molar mass is grams per mole, so we put grams on top and moles on bottom to cancel out. And so we find that in 1 mole of lithium, there's 6.95 grams of lithium. And then we can do the multiplication after we cancel some things out, and we find that it's 4.51 grams of lithium. Now, if we wanted to go from grams to moles, again, we're going to use lithium. So we're going to start off here with 18.2 grams of lithium. What's the molar mass of lithium? It is 6.941 grams per mole. And so we're going to put grams on bottom because we want to cancel out our grams. We put moles on top, do our cancellation, and we find that we have 2.62 moles of lithium. Now let's do a calculation involving using Avogadro's number. And so what we will see here, let me correct this, let's start over. Now let's do a calculation using Avogadro's number. So the question is, how many atoms of lithium are in 18.2 grams of lithium? So first off, we need to convert grams to moles, and then we can go from moles to atoms, because Avogadro's number is the number of atoms in a mole of anything. And so when we look at this, we're going to take our 18.2 grams of lithium, and then 1 mole of lithium is 6.94 grams of lithium. And then there are 6.022 times 10 to the 23rd atoms of lithium in a mole of lithium. So we always like to double check and make sure things cancel out. So we can cancel out grams, we can cancel out moles, and we're left with atoms. And so when we do the calculation, 18.2 times 6.022 times 10 to the 23rd divided by 6.94, or in our factor label method, we multiply what's on top, we divide by everything that's on bottom, and that's going to give us 1.58 times 10 to the 24th atoms of lithium in 18.2 grams of lithium. Now, we've already looked at the molar mass of an atom, which is exactly what's found on the periodic table. And now we want to look at molar mass, formula mass, however we want to say it, it all kind of works out the same way, of compounds. And so we have magnesium carbonate. So the way that you figure this out is you look up magnesium, carbon, and oxygen on the periodic table, and then add up those, but you have to multiply by an individual subscript. So what I mean by that is when we look at this, so 24.31 is magnesium, carbon's 12.01, and then oxygen is 3 because there's a subscript of 3, times 16, which is the molar mass. And so when we do this, we come up with 84.32 grams, and that would be the formula mass or the molar mass of magnesium carbonate. I trust that you enjoyed this video. Thank you again for watching St. Clair Chemistry.